S. Chan presents educational video lectures as per the new UGC CBCS curriculum. Absolutely free. Difficult concepts made easy. Study anywhere, anytime.
Everybody loves curve, drawing, designing, tracing, but do you know when we draw anything, when we trace anything, there is a lot of mathematics. Hi everyone, I am Dr. Seema Thakran. Welcome to S. Chand Academy. In this lecture, we will be studying how to trace curves, and first I will be taking how to draw a curve which is in Cartesian form, that is in x and y form. If you want to study this topic in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box. So let's start with curve tracing. To trace curve, you should be knowing some of the points. So I'll first brief you the points you should know before tracing any curve. As I told you, curve tracing will be doing, but this curve tracing is for Cartesian curves. What does Cartesian means? Cartesian curves. It means your equation, your curve will be in x and y form. So your curve is of this form, y is equal to fx. This will be the form of the curve. This type of curves we'll be learning how to draw in this lecture. So very first thing is symmetry. What symmetry means? Symmetry is this. You can see the curve is this parabola. This is parabola. This parabola is symmetric about this line, and you know this is your y-axis. So you can see both the shape of the curve is symmetric about y-axis. So this is symmetry. How to check symmetry? When you have curve equation, how to check symmetry? Very first point, symmetry about if x powers in the curve are even powers. Even, you know, 2, 4, 6, 8. So power of x, if it is even, your curves will be symmetrical about y-axis. Symmetry about x-axis. About x-axis I will say. So about x-axis, if y powers are even, if both x and y powers are even, then you can say symmetry about both axes. Symmetry about both axes. If x and y both have even powers. What does this even powers means? I am giving one example so that you get better idea. So x powers are even, then symmetry about y-axis. So you know this parabola, and the same parabola I have drawn. You can see symmetry about y-axis. This parabola, the drawing or tracing is this. This is symmetrical about y-axis. Y powers are even, then symmetry about x-axis. So the example is y square equal to 4ax. That is the example. If you draw this parabola, I just draw it here only. This is the parabola. You can see symmetry about x-axis. So this is your x-axis symmetry. You can see clearly. If symmetry about both axes. So very basic example, and that is your circle. Very basic example. This is the circle. And you have already start knowing these things in your 8th, 9th onwards. So this is your circle, and you can see symmetry about, this is center is 0, 0, radius is 1. So you can see the symmetry about y-axis and x-axis both. So this is symmetrical about both the axes. Now symmetry part is over. Next, second point is origin for curve tracing. And what does that mean? origin is 0, 0. So what you will do, you will put x equal to 0, y equal to 0 in the curve equation, and if the equation gets satisfied, you will say that the that the origin is lying on the curve. I am taking one example again. So this is the example. This is parabola. So if you will put x0, y0, you can see 0 equal to 0. It means on this parabola origin is lying, and from here also you can see that the curve is lying, means the curve is passing through the origin. But if you see this circle equation, if you are putting x equal to 0, y equal to 0, 0 not equal to 1, it means the origin is not lying on this circle. Now next point. If you want to study asymptotes part in detail, you can refer to my lecture, 7th lecture. But a little brief I will be giving here. Asymptotes, 3 types of asymptotes. First is parallel to x-axis, parallel to y-axis, and oblique asymptotes. This I have already explained you in my 7th lecture. So you can refer to the lecture to go in detail for asymptotes. What you do for parallel to x-axis when you are calculating, what you do, put the highest degree of y equal to 0, and vice versa for y-axis. If you are calculating with respect to x-axis, what you will do, highest degree coefficient of highest degree coefficient I should add, because coefficient you equate to 0. Parallel to x-axis asymptote, if you are calculating, put the highest degree coefficient of y equal to 0, you will get the asymptote parallel to x-axis. Same thing you can do for y-axis. Put the highest degree coefficient of x equal to 0, you will get the asymptote parallel to y-axis. For oblique asymptotes, please refer to the lecture 7. Now moving to the intercepts. Intercepts means intercepts with x-axis and y-axis. What you will do to get these intercepts? First, put x equal to 0, get values of y from the equation. Get values of y. So you will get points like 0 and whatever value of y you will be getting. If these are 2, 3, then those 3 points you will be writing in this form, because x is 0 na, so you can fix x 0 and y values you will keep putting and you will getting the points. Then for x0 means what? X0 means on this line you have x0, on this line x0, on this line y0. So it means if your x is 0, the points will be on y-axis. And then for x-axis, put y equal to 0. On this complete line your y is 0. So put y equal to 0, get values of x. And these values you are getting from the given equation of the curve. So points will be of the form x, because y is 0. So some x will come here. It might be 0, no issues, but some x value you will get. Y is fixed, y is 0. So these points, this is the 4th point. First was symmetry, then the next point was origin, then asymptotes, then intercepts. Moving to the next point, singular points. So singular point, basically what is a singular point? A point or a point is said to be, I will start with definition because this point I haven't explained in my earlier lectures. So a point is said to be singular. It has 3 names. Please note that singular point we can say, multiple point we can say, or double point we can say. So you can all have same meaning. एक point singular कब होगा? If R tangents is singular, if 2 or more tangents pass through that point. It has three definitions. If your point is singular, then it has three main points. What are the points? First is node, second is cusp, third is imaginary tangents, or imaginary, because we are in real world, so imaginary part we never consider. Node and cusp, what does it mean? It means your singular point is a node, your singular point is a cusp. The graph, cusp means you will get two tangents. Tangent part also we have discussed in our earlier lectures. So you can refer to those lectures to understand like how we find tangents. So for cusp, two tangents, but same, both will be same, but same tangents. Then for node, two tangents, two different tangents, different tangents. If it means at that point, if you are getting two tangents but same, then you will say it is a cusp. If two tangents but they are different, then you will say it is a node. If in case your tangents are imaginary, then that is the last point. We never consider this point anyhow when we trace the curve, because this is imaginary tangent. Now, sign of derivative. Sign of derivative, suppose you have in this interval, because you will get points when you will solve the curve, you will get points. Suppose 0, 1, 2, then you can make your intervals. You can make intervals like this, 0, 1, 1, 2, and you want to know the behavior of the curve, whether it is increasing, decreasing, maximum, maxima, minima. So what you do? Make any interval and check the sign at that particular point. Suppose your derivative at that in this particular interval is greater than 0, you will say the curve has increasing behavior. The curve is increasing. Suppose your derivative is less than 0, then you will say your curve is decreasing in this interval. So it becomes easy to draw in that particular interval the curve. You can just take the curve in the decreasing manner, or if it is positive, then you will be drawing it in upward direction or positive direction. Now sign of second derivative, how it will help to draw curve. The same, any interval you can consider. I am taking it again AB. So second derivative means, suppose your second derivative, you know how to find out derivative. Differentiation also we did in our second lecture. So please, if you are not good in derivatives, refer to this second lecture. So second derivative, suppose positive, you will say convex curve. What does it mean? It means the shape will be like this, holding the water. In easy manner we say that your curve will be holding the water. Okay, it will not spill if it is positive. Suppose it is negative in that particular interval, then you will say it is concave, and it means it will spill the water. So the shape will be like this. In that particular interval, the shape will be this type. Is this fine? Now, so 7 points we have already discussed. Coming to now region part. This is also important point when we are tracing a curve. Region, what does it mean? Like how you will calculate. So what you will do? You will get, you have this equation na? Just check where this equation, for what values of x and y this equation is satisfying. It means for x values, y should not be imaginary. Y should not be imaginary. You are considering only the part where your curve is lying. It means for x, y should have real values. If it is having imaginary values, you will not consider that point. The same thing you will do for y, values of x should not be imaginary. So both ways you will be solving to know where your curve is lying or not lying. Both things you will be checking in this region you will be calculating. So both you will be calculating. Now coming to tangents part. So tangents I have already discussed in my earlier lecture, but again I will be discussing this part because tangent at origin is very important. If origin is lying, how to find tangent at origin? Suppose your curve is this. Just check the lowest degree. Degree means this has 3 power, this has 3 power. So this is 3. Check the degree of this term now. This is 1 plus 1, 2. So lowest degree in this equation is this one. First take it to this side. We always take the curve to one side. So now your lowest degree is xy. So lowest degree equal to 0 will give you the tangents at origin. Is this okay? So to origin, for particularly origin, if you are calculating, then simply put the lowest degree term equal to 0. x0 means y-axis is the tangent and y0 means x-axis is the tangent. So these are the important points you should be knowing to trace a curve. Just recall again what we did. I'll start with the beginning. So first point was just recall again symmetry, then origin, then asymptotes, then intercepts with x and y axis, next is singular points, sign of the derivative, sign of second derivative, then region, tangents and at origin. It's not that tangent at origin is only important, tangent at every point is important, but for rest of the points we have already discussed. At origin I have told you the simplest method, simply put the lowest degree term equal to 0. So these are the points you should be remembering, learning to when you are coming to tracing a curve. So let's start with the example, but very simple examples. Please first, before coming to the complicated curves, first you should be knowing all these curves. It's not that for every curve you are just keeping all those 9 points in your mind. These curves are very simple curves. Before proceeding to trace difficult curves, please you should be knowing all these basic curves. These are very basic curves. You should draw very quickly. It's not that for you putting all the points and all. So please I will be just discussing one question after the break, and the question is trace the curve, and after the break I will tell you like what are these curves if you don't know. So trace the curve, and after that I will take this example. One of the good example, difficult to draw and difficult to find out all the points. So after the break we will discuss this question.
Welcome to S. Chand Academy. Myself Dr. Mamta Sethi, and I am here to explain you the various concepts related to the states of matter and chemical kinetics. So stay connected, like, subscribe and share, and do not forget to press the bell icon.
Welcome back to S. Chand Academy. So before going to the break, we did curve tracing main points. So main point first was symmetry. Just addition to symmetry, one addition, please make one addition, and that is symmetry about the line y is equal to x. So how to check if whether your curve is symmetrical about this line or not? This is the line making 45-degree angle and it passes through origin. How to check? Just exchange x and y in the equation, y by x and x by y. If your equation remains the same, you will say your curve is symmetrical about y is equal to x. So one addition only in symmetry. Symmetry about y-axis we have already learned, then about x-axis, about both axes. This is another addition you should be knowing. Symmetry about the line y is equal to x. How you will be checking? Exchange just y by x and x by y. If your equation remains the same, you will say the curve is symmetrical about the line. Now all the points, on the basis of all those points, will be tracing the curve. One example I have already written, but before moving to this is circle with center 0, 0, radius 1. This is parabola. This is your parabola. Y power is even. You can see symmetry about x axis. This is this parabola. This is this parabola. Then this is ellipse, an elliptical shape, egg shape you can say. So this is your, depends on whether A is greater than B or not. In this case I have taken A greater than B. If in case B is greater, your shape will look like this. So these basic curves at least you should be knowing. For such curves you don't require curve tracing. Now you can see the example which we were discussing, which I gave you before the break. Now I will discuss this. So all points first we just calculate, then we will start drawing. So for the solution, first point was symmetry. Now for symmetry, what I told you, if the curve is symmetrical about x axis, the y power should be even. You can see y power is odd, x power is odd, it means the curve is not symmetrical about x axis and y axis. Then the symmetry about both, 100% it cannot be, because you can see both the powers are odd powers. Now symmetry about y line y is equal to x, that is existing. So for this line symmetry, what you will do, you can see if you are changing your x by y, the same equation you are getting. Just change your x by y by x, the same equation you can see, it's just exactly the same. It means your given curve is symmetrical about this line. So symmetry about the line y is equal to x. This line, any general equation of a line is this. If you compare this line, you can see your c is 0, you can compare, and m is 1. m1 means tan theta is 1, it means where you get tan theta 1, that is 45 degree. These things also you should be knowing in detail. So in pi form we write it like pi by 4. So it means this is the line making angle 45 degree with the x axis. It passes through origin, put x0, y0, so the origin is also, this line passes through origin. Next point is origin on the curve, whether your curve, given curve is passes through origin or not. Put x0, y0 in the equation of the curve, x0, put x0, y0, you can see both LHS and RHS are same, x0, y0, so LHS equal to RHS. This implies the curve passes through origin, the curve passes through origin. This is our second point. Now third is asymptotes. It's not that every point will be just having something for tracing curve. If it is giving you something for tracing the curve, it's fine. Otherwise, if it is not, then also it's fine. So we'll get enough information to draw the curve from these points. So asymptotes, if you are putting the highest degree of x equal to 0, that is coefficient is 1, it will be absurd 1 equal to 0. And if you are putting highest degree of y equal to 0, coefficient basically, so 1 equal to 0 means then again absurd, it means there is no asymptote parallel to x axis and y axis. So no asymptote parallel to x axis and y axis in this case. But in my asymptote lecture, that was 7th lecture, I calculated the asymptote particularly for this equation or for this particular curve, the oblique asymptote. Refer to that lecture to get the asymptote equation. Oblique asymptote was x plus y plus a equal to 0. So, asymptote we got to know. Next point is, intercepts will be calculating. For intercepts, what you will do? You will put x equal to 0, you get the values of y in case it is giving you some x value, y values, and then for you will put y 0, then you will see what x values you are getting for the intercepts with x's, with x and y axis. Put y equal to 0 first. When you are putting y equal to 0, your equation is this. Put y equal to 0, what you will get? X cube equal to 0. This is 0, this is 0. So, it means x 0. It means whether you put x 0, y 0, only origin you are getting. Only 1 point you are getting. And that is origin. If origin is lying and then tangent, also you should calculate tangent. For tangent at origin especially, what you will do? The lowest degree term, that is xy, put that equal to 0. It gives you x 0, y 0, because product is 0, so both should be either any one 0 or both 0. So, either x is 0 or you can say y is 0. This implies x 0 means what? Y axis is the tangent and y 0 means x axis is the tangent. So, this is the fourth point. For the fifth point, it's not that in the same order I have given you the points. It's not order you can change, but you have to calculate. You should be knowing all the points before tracing. So, region point I am discussing. Just see the equation of the curve. It means you are observing your equation very carefully, very deeply. Now, put just change x to minus x, y to minus y. Why I am doing this? Because I want to know in which quadrant. This is the quadrant where x is positive, y is positive, both are positive. In this quadrant, x is negative, y is positive. In this case, both are negative. In this case, your y is negative but x is positive. So, these are the cases. I am just checking कि in कौन से वाले portion में आपका curve lie नहीं कर रहा है. So, this is, it means I am just checking particularly for this quadrant. For rest of the quadrant, there is no issue and we cannot check directly that way. So, check करिए. So, it will give you this, because minus minus will become positive. It means your equation is this. You can see जब आपने third quadrant के points डाले तो आपका curve satisfy नहीं हो रहा है. It means in any case आपकी जो picture है वो third quadrant में नहीं आएगी in any case, because उसके points curve को satisfy नहीं कर रहे हैं. So region also point we have discussed. Region is done. Now another point is, this was fifth point, so moving to the sixth point. What you should be doing, always take derivative also. So for derivatives, your equation was x cube y cube 3axy equal to 3xy. Take the derivative, and for derivative it's not. So 3x square, then 3y square, y is a function of x, so 3y square, and y derivative you will not forget. Here you will be just applying the product rule, and product rule says first same derivative of second, then second same derivative of first. Collect the coefficients of dy by dx one side. And the rest at once on the other side. So your derivative 3 will get cancelled throughout. So you are left with this. this is your derivative. So dy by dx you are getting as, ये आपके पास डेरिवेटिव आया, now the last point before proceeding to draw the curve. Derivative, I am just keeping it on hold. Why? Now we know that our curve is symmetrical about y is equal to x line. So what do? You should be checking कि कर्व आपका इस लाइन को कहाँ, एक्स एक्सिस पे कोई कट नहीं है 0 0 पे, वाई एक्सिस पे कोई कट नहीं है, लेकिन इस लाइन पे कुछ अगर कट है तो वो और चेक कर लेते हैं. द लास्ट थिंग टू चेक, y इक्वल टू एक्स इक्वेशन में डालो. सो आपके पास जो इक्वेशन आएगी, यू कैन सी y को x इक्वेशन में सब्सटीट्यूट कर रहे हो. सो योर इक्वेशन गिविंग यू y को आप x सब्सटीट्यूट कर रहे हो. सो कंप्लीट इक्वेशन विल बी ऑफ y. Take it to one side, y square common, then y, this implies, what this implies, y 0 and y equal to, so ये आपके पास दो पॉइंट्स आ रहे हैं. अगर y 0 है और आपने y इक्वल टू x डाला है तो x भी क्या हो जाएगा 0. y 3a/2 है तो y और x सेम है तो x की वैल्यू क्या बन गई. समटाइम्स आपको प्रॉब्लम होती है पॉइंट्स लिखने में, सो वो पॉइंट्स लिखने में प्रॉब्लम ना हो इसके लिए पॉइंट्स क्या है आपके, y के करस्पॉन्डिंग x इज 0, इट मीन्स फर्स्ट पॉइंट आपका बना 0 0. y के करस्पॉन्डिंग ये पॉइंट आ रहा है, इट मीन्स ये वाला पॉइंट है. डोंट मिस मैच द पॉइंट्स. कई बार बच्चे क्या करते हैं कि वो 0 3a/2 0 ले लेते हैं, देन 0 3a/2 लेते हैं. दैट इज नॉट द पॉसिबिलिटी इन दिस केस. आप वही पॉइंट लोगे जैसे y के करस्पॉन्डिंग x ये आ रहा है, तो इट मीन्स दिस इज दी पॉइंट जो हमें लेना चाहिए. अब ओरिजिन पे जो पॉइंट्स आपके आ रहे हैं, ओरिजिन पे आप ऑलरेडी टेंजेंट की बात कर चुके हो. इस पे अब एक बार टेंजेंट की बात बहुत इंपॉर्टेंट है. जितने पॉइंट्स आपके इंटरसेप्ट पॉइंट हैं उन पे सब पे आपको टेंजेंट ज़रूर कैलकुलेट करनी है. टेंजेंट के लिए इस पॉइंट पे टेंजेंट चेक करते हैं. डेरिवेटिव आपका ऑलरेडी यहाँ पे मेंशन किया हुआ है. जस्ट चेक द टेंजेंट एट दिस पॉइंट ओनली, द लास्ट पॉइंट. So tangent at 3a/2 3a/2 क्या करते हैं, कैसे करते हैं, y minus this point, this is y point. Now the slope of the tangent at this point, जब आप इसमें 3a/2 3a/2 डालोगे ना, यहाँ पे इस पॉइंट पे आप स्लोप चेक कर रहे हो टेंजेंट का, कैसे आप सब्सटीट्यूट करोगे, इस पॉइंट को इसमें सब्सटीट्यूट करो और देखो कि क्या आ रहा है. और कैलकुलेशन जो है डू दैट वेरी केयरफुली. सो 3a/2 जब आप डाल रहे हो, बोथ द पॉइंट्स आर सेम. आप देखो कि बिल्कुल एग्जैक्टली सेम है, सिर्फ नेगेटिव का डिफरेंस है. दोनों इक्वेशन सेम है. इट मीन्स आपका जो डेरिवेटिव ऑफ -1 आ रहा है इस पे. बोथ द एक्सप्रेशंस न्यूमरेटर डिनोमिनेटर आर सेम, इट्स जस्ट ओनली अ डिफरेंस ऑफ नेगेटिव ओनली. माइनस आप बाहर लोगे. सो -1 x minus 3a/2. अब आप इसको थोड़ा सा सिंप्लीफाई कर लो. जब आप इसको सिंप्लीफाई करोगे, सो योर इक्वेशन विल लुक लाइक टू रिमूव कर दो, इस 2x को इधर लेके आओ और इस 3a को भी इधर लेके आओ. सो ये बन जाएगा 6a. Just completely take out x 2 common. So this is your. So all the points we got to know. Now the last part is I will drawing the curve and how come we'll be just getting that idea कि ये कर्व कैसा है, कैसा लगेगा. अब आप सारे पॉइंट्स आप नोट कर लिए हैं आपने. आप ड्राइंग देखिए. The last part, so big graph, y equal to x line, this is your y equal to x line. Line I will be taking in dot form, the curve will be in, so this is your y is equal to x line. I told you na, this makes 45 degree angle with the x axis. or it is passing through the origin. So through origin, and this is the line. Then your x plus y asymptote, this was asymptote. I hope you know in 12th class you have already done how to draw a line. कैसे करते हैं 2 point form से, एक बार x को 0 डालो, y की वैल्यू माइनस a आ रही है, एक बार y को 0 डालो, x की वैल्यू माइनस है. दिस इज हाउ यू ड्रॉ एनी लाइन. सो अब आपका माइनस a पॉइंट यहाँ पे है और ये वाले पॉइंट्स, दिस इज y नेगेटिव, दिस इज x नेगेटिव. इट मीन्स आपकी ये वाला जो लाइन है ना, दिस इज योर एसिम्टोड. एसिम्टोड आपको बताया था कि कर्व कभी भी एसिम्टोड को टच नहीं करता है, उस लाइन को टच नहीं करता है, उसके पैरेलल साथ में चलता जाता है. देन अब ये 2 पॉइंट्स हमने किए. अनदर थिंग इज आपकी ये जो लाइन है ना, ये वाली लाइन, ये है आपकी टेंजेंट. अगर आपने नोटिस किया ओरिजिन पे ये टेंजेंट है, इसका मतलब कर्व यहाँ पे ओरिजिन पे सिर्फ एक ही पॉइंट पे टच कर सकता है. देन आपकी ये लाइन भी टेंजेंट है, एक्स एक्सिस भी टेंजेंट है, यानी यहाँ पे भी एक ही पॉइंट पे टच करेगा, इसके ज़्यादा टच नहीं करेगा. थर्ड क्वाड्रेंट में बिल्कुल लाइन नहीं करेगा कर्व आपका. सो ये सारे एंड इस लाइन पे कितने पॉइंट्स ऑफ इंटरसेक्शन आ रहे थे आपके, एक तो 0 0 आ रहा था पॉइंट ऑफ इंटरसेक्शन, और एक आ रहा था 3a/2. 3a/2 कितना बनेगा, 3a/2 मीन्स 1.5a. ठीक है, अगर सपोज a यहाँ पे है तो और 2a यहाँ पे है तो आपका 1.5 यहाँ बनेगा. ठीक है, और यहाँ पे भी सेम वे आप इसको कंसिडर कर लो. सो यानी यहाँ कहीं ये कट करेगा. ठीक है, आप 3a/2 सिमेट्री जो है इस लाइन के अबाउट है. यानी अगर आपको इस लाइन के ऊपर पिक्चर पता चल जाए, नीचे आप सेम वे आप इस पे पिक्चर ले सकते हो. नाउ स्टार्टिंग विद द ड्राइंग. अब आप देखो ये एसिम्टोट है और ये लाइन टेंजेंट है इस वाले पॉइंट पे. आपकी जो टेंजेंट है इट मीन्स यहाँ से आप, और ये वाला पॉइंट और ये पॉइंट अगर इंटरसेप्ट करें जनरली तो हम आप और 0 to 3a/2 में आप डेरिवेटिव से देख सकते हो कि जो डेरिवेटिव है ना वो पॉजिटिव रहेगा. इट मीन्स आपका जो कर्व है दिस विल टेक, इंक्रीज करा आपने इसको. ठीक है, और बिकॉज अब आप ये पॉइंट टेंजेंट, दिस इज टेंजेंट एंड दिस इज एसिम्टोट, तो यू विल प्रोसीड दिस वे टिल इन्फिनिटी. अब आपने एक अगर इसके कर्व के सिमेट्री अबाउट, तो देन दिस पिक्चर बिकॉज ऑफ द सिमेट्री ये ऐसे सिमेट्री आएगी और यू कैन सी द बिहेवियर ऑफ द डेरिवेटिव. यहाँ पे इंक्रीजिंग जाएगा, यहाँ पे इसमें डिक्रीजिंग जाएगा, और ये एसिम्टोट है, ये टेंजेंट है. सो द दिस विल थर्ड क्वाड्रेंट में पिक्चर आएगी नहीं. सो ये पिक्चर यहाँ पे टेंजेंट है, ये एक पॉइंट को टच कर रहा है, एंड दिस विल बी द ग्राफ ऑफ द इक्वेशन. सो ये सारे पॉइंट्स के बेसिस पे वी हैव ड्रॉन दिस कर्व. यू शुड note down each and every point before drawing because it is important, because in rest of the picture there is no curve lying. You can check the rest of the points will not satisfy the curve equation. So this is one of the important curve. You should be knowing the asymptote equation. You should learn some points when you are solving. It makes your work easy when you are in your exam. So this is done. One example I can just give you for practice, and the question is this: x by a to the power 3/2. The equation looks difficult, but you can just try this question. In case you are not able to, then you can refer to the books, or in the next lecture we can discuss the solution. So this is it. We have learned curve tracing in Cartesian form in this lecture. If you want to study this topic in detail, please refer to the book by S. Chand Publishing. E-book link is given in the description box. Don't forget to share, like and subscribe. Don't forget to press the bell icon for the future updates. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.